Hello, everyone, and welcome to our BME298 final project.
For the BME298 project, we focused on the medical issues of bunions. Bunions, more formally known as hallux valgus, is a common foot deformity formed in about 20 to 25% of the populations. This foot deformity is caused when the joints and the bones in the front part of the big toe or the hallux start to move out of place, producing a big bone bump in the side of the foot. The unaligned big toe starts to affect the other toes, making them bend to the side, and depending on the severity of each bunion case, it can affect many parts of the patient's daily life. Figure 2 shows a different severity of bunions present. In the moderate cases to severe cases, there's a drastic difference.
The real problem with bunions boils down to three main parts. Number one, bunions are pain to many patients. Number two, even though there are surgical options, they don't eliminate this bone bump completely and have a recurrence rate of 25%. And number three, majority of the treatments from the last slide are more passive treatments and not actively or aggressively solve the issue. Resolving this problem is important since bunions have affected a significant amount of the population and will continue to do so until more novel ideas and concepts are created to solve and eliminate them altogether.
Because of the background information that was just provided, we need a more active way to treat bunions, which leads to our needs statement of a way to address not only bunion prevention, but also bunion regrowth and reformation after initial bunionectomy surgery in patients with bunion issues and foot deformities in order to reduce the rate of occurrence and recurrence of bunions.
In this project, we use a 3D printer to build a case for the Arduino and the breadboard so that it holds both these tools near the foot. This case is a slit that slides into the sole of the foot, which we laser cut. The sensor is then connected to the big toe to detect any de-alignment. The screenshot in this slide is the case with the Arduino, the breadboard, the motor, and the flex sensor represented and labeled.
This slide walks through our code and our thought process when creating the code. This novel concept solution allows for the doctor to set up the calibration value, which is the correct position for the patient's big toe alignment. Then we recommend the patient to wear this device as needed. The patient can wear it at home, and all they need to do is press a button to start the aligning process. The flex sensor will read a voltage value and compare the alignment to the base value set by the doctor to either increase tension in the spring or loosen it up. The timing will better align the big toe and help in preventing bunions from forming again.
Here's our code, and we will now watch the video.
Ladies and gentlemen, welcome back to another awesome BME video. In this video, we shall demonstrate the bunion destroyer, the foot protector, the one and only toe aligner. The main concept of this medical device is that when the patient clicks the button, it tests for disalignment in the toe using a flex sensor. And if the sensor finds the toe unaligned, the stepper motor will rotate clockwise, applying tension in the string to pull and realign the toe. If it finds it aligned, it will loosen up a bit. For safety concerns, there is a red LED indicating the device is connected, which it is right now, and it will blink when the motor is in operation. As you can see, since the toe model is already aligned, the stepper motor should rotate to release pressure and tension from the toe, just like that. However, if there is a bend in the toe, then it should rotate the other way to increase in tension.
Thank you for listening and hope you learned something new from our presentation. We are happy to answer any questions. Also, best of luck on the rest of your trials.